morning all. So in today's class, we'll look at a few more examples of Sturm-Liouville problems. So the first question is, so you need to find the characteristic value and characteristic functions of the equation d by dx of x dy by dx plus lambda by x y equal to 0. And they are given y at 1 equal to 0 and y of e raised to pi is equal to 0. So here there is no condition upon lambda given. So lambda will have three choices. So lambda can be either 0, it can be positive, or it can be negative. So when lambda is equal to 0, we will get second term 0 out. So you will get d by dx of x dy by dx equal to 0. So the derivative is 0. So upon integrating, you will get x dy by dx equal to c. The variable separable ആയിട്ട് എടുക്കുക. അപ്പോൾ dy will be equal to c dx by x. So therefore the solution is going to be y equal to c log mod x plus c naught. Ini initial conditions apply ചെയ്യുമ്പോൾ y at 1 is 0. 1 substitute ചെയ്യുമ്പോൾ first term 0 ആവും. So that will give c naught equal to 0. ഇനി അതുപോലെ y of e raised to pi equal to 0 എടുക്കുമ്പോൾ you will get 0 equal to c ln of mod e raised to pi. C naught is 0. So this will be equal to pi. So you will get c equal to 0. So both the arbitrary constants are 0. So you are getting a trivial solution here. So there is no non-trivial solution when lambda is equal to 0. And again, when lambda is less than 0, what we get is, so we will have x d square y by dx square plus dy by dx plus lambda by x y equal to 0. So the equation can be multiplied throughout with x. So it can be written in the form x square d square y by dx square plus x dy by dx plus lambda y equal to 0. So this is the Cauchy-Euler equation. So by using the substitution x equal to e raised to t, this can be converted to an equation involving constant coefficients. So substitution ചെയ്യുമ്പോൾ you will get d square y by dt square minus dy by dt വരും plus x dy by dx will become dy by dt plus lambda y equal to 0. So dy by dt cancel out. So the equation will reduce to d square y by dt square plus lambda y equal to 0. Ni auxiliary equation is auxiliary equation will be m square plus lambda equal to 0. So the roots will be plus or minus root of minus lambda. Ni lambda negative ആണ്. Lambda negative ആയതുകൊണ്ട് now under the square root it will be positive. So therefore the roots are going to be real and distinct. അപ്പം roots real and distinct ആണ്. So let me take alpha equal to root of minus lambda. So we will get the solution as y equal to e raised to alpha t plus c2 e raised to minus alpha t. We substitute back for t. So e raised to t will be x. So you are going to get y equal to c1 x raised to alpha plus c2 x raised to minus alpha. Okay. Now use the initial conditions, boundary conditions. So you will get y of 1 equal to 0. From x and 1 കൊടുക്കുമ്പോൾ you will get c1 plus c2 equal to 0. And y of e raised to pi equal to 0 gives c1 e raised to pi alpha plus c2 e raised to minus pi alpha will be equal to 0. So let us look whether it will have a non-trivial solution or not. If a non-trivial solution exists, the determinant must be 0. So determinant edukumbo that will be e raised to minus alpha pi minus e raised to alpha pi. So that will be equal to 0 only when alpha is equal to 0. Now alpha cannot be 0 since we started with lambda less than 0. Alpha equal to 0 ആവാൻ പറ്റില്ല. So therefore there will be no non-trivial solution. And let us look at the third case, that is when lambda is greater than 0. So lambda greater than 0 varum. So again Euler-Cauchy equation which you will get the equation as d square y by dt square plus lambda y equal to 0. So auxiliary equation will be m square plus lambda equal to 0. So m will be plus or minus root of minus lambda. Means lambda greater than 0 ആണ്. So we started with case 3 where lambda is greater than 0. So root of minus 1 will be I. So you will get plus or minus root lambda I. So the roots are complex. So therefore the solution y will be equal to C1 cos root lambda t plus C2 sin root lambda t. So upon substituting back t, so t will be log x. So you will get y equal to C1 cos root lambda log x plus C2 sin root lambda log x. Conditions apply here. So y of 1 equal to 0 gives, so ln of 1 is 0, sin 0 0 cos 0 will become 1. So that will give C1 equal to 0. So now C1 is 0. രണ്ടാമത്തെ condition എടുക്കുമ്പോൾ y of e raised to pi is 0. So C1 0 ആണ്. അപ്പോൾ second term മാത്രമേ വരുള്ളൂ. അപ്പോൾ C2 sin root lambda log e raised to pi. That will be equal to 0. So log e raised to pi will be pi. So you will get C2 sin root lambda pi equal to 0. If C2 0 ആവാൻ പറ്റില്ല കാരണം you will get a trivial solution then. So therefore sin root lambda pi must be 0. So that gives root lambda pi must be equal to n pi where n is greater than 0. So therefore pi will cancel out. So you will get lambda equal to n square. So therefore we will get a non-trivial solution when lambda is n square where n equal to 1, 2, 3 etc. ഇനി ഇതാണ് നമ്മുടെ characteristic values. So corresponding characteristic function will be C1 is 0, y will be C2 sin root lambda log x. So corresponding to each n, the characteristic functions are going to be y equal to Cn sin n square log x. So these are the characteristic values and characteristic functions. Okay, sorry, here I have written cos, that is sin. Please make that correction. Okay, so characteristic values are lambda equal to n square and characteristic functions are y equal to Cn sin n square log x where n is 1, 2, 3 etc. Okay, so let us see one more problem. So you are given d by dx of x square plus 1 dy by dx plus lambda x square plus 1 y equal to 0, and the conditions are y at 0 equal to 0 and y at 1 is equal to 0. Now again here also we have three cases, that is when lambda equal to 0, lambda greater than 0 and lambda less than 0. So lambda equal to 0 ആവുമ്പോൾ second term മൊത്തം 0 ആവും. So you will get d by dx of x square plus 1 dy by dx equal to 0. So that will give x square plus 1 dy by dx equal to c. Now use variable separable form for dy equal to c dx by x square plus 1 varum. So therefore the solution will be y equal to c. This is the integral edukkumbol that will give tan inverse of x plus some arbitrary constant c naught. So y is going to be c tan inverse of x plus c naught. Ni conditions random apply here. So y at 0 is 0. So tan inverse of 0 0 aanu. So you will get c naught equal to 0 from the first condition. Ni y of 1 equal to 0 will give c tan inverse of 1 equal to 0. Because c naught already 0 aanu. Tan inverse of 1 is pi by 4. So that cannot be 0. So therefore we will get c equal to 0. So both C and C naught are 0. So therefore we only have the trivial solution. So there is no non-trivial solution when lambda is equal to 0. Now let us look at the case where lambda greater than 0. Now lambda greater than 0 ambo. So your equation can be written as, so derivative edukumbo you will get x square plus 1 d square y by dx square plus 2x dy by dx plus lambda y by x square plus 1 equal to 0. Okay. So this will be the equation. For this equation, for solving this, we will use a substitution x equal to tan t. Okay, because here you have constant coefficients alla. So let us use this substitution, and now the equation will be converted to constant coefficients under the substitution. Okay, for x equal to tan t edukumbo, you will get dx equal to sec square t dt. So dx by dt will be sec square t. Now let us find out dy by dx. So by chain rule, dy by dx will be dy by dt into dt by dx. Dy by dt, okay, നമുക്ക് x by dt അറിയാം. So therefore dt by dx will be 1 by sec square t. So you will get 1 by sec square t dy by dt. So that is equal to 1 by 1 plus x square dy by dt. Now let us look at the second derivative. So d square y by dx square. So by definition that is d by dx of dy by dt. Dy by dx will be a function of t. By chain rule, this will be equal to d by dt of dy by dx into dt by dx varum. നമുക്ക് already dy by dx നമ്മൾ ഈ സ്റ്റെപ്പിൽ കണ്ടുപിടിച്ചു. In terms of t, that will be equal to this. അത് substitute ചെയ്യാം. So you will get d by dt of 1 by sec square t dy by dt into 1 by sec square t, that is dt by dx. ഇനി നമുക്ക് ഇതിന്റെ ഡെറിവേറ്റീവ് എടുക്കണം. So 1 by sec square t എന്ന് പറയുമ്പോൾ that will be cos square t. So ഡെറിവേറ്റീവ് എടുക്കുമ്പോൾ, so 1 by sec square t പുറത്ത് തന്നെ കിടക്കും. ഈ പ്രോഡക്റ്റ് റൂൾ വെച്ച് ഇതിന്റെ ഡെറിവേറ്റീവ് എടുക്കാം. ഓക്കെ, അപ്പൊ cos square t യുടെ ഡെറിവേറ്റീവ് മൈനസ് 2 cos t sin t dy by dt വരും, പ്ലസ് ദിസ് ടേം ഇൻറ്റു ഡെറിവേറ്റീവ് ഓഫ് dy by dt with respect to t. അപ്പം 1 by sec square t d square y by dt square വരും. And when you multiply 1 by sec square t inside, so this is what you are going to get. Okay. Now let us substitute the derivatives in the given differential equation. അപ്പോൾ നമ്മുടെ dy by dx ഉം d square y by dx square കണ്ടുപിടിച്ചു. ഇനി x square plus 1 എന്ന് പറയുന്നത് that is 1 plus tan square t. So that is equal to sec square t. Then substitute d square y by dx square substitute ചെയ്യുക. Then 2 tan t വരും ഇവിടെ. dy by dx will be cos square t dy by dt plus lambda. This is 1 by sec square t. 1 by x square plus 1 എന്ന് പറയുന്നത് 1 by sec square t വരും. So that will be cos square t y equal to 0. ഇനി ആദ്യത്തെ ടേമിൽ sec square t multiply ചെയ്യുക. So you will get minus 2 sin t cos t dy by dt. രണ്ടാമത്തെ ടേം is 1 by sec square t d square y by dt square വരും. അതായത് cos square t d square y by dt square വരും. Then plus 2 ഇനി this is sin t by cos t. അപ്പോൾ cos t കാരണം cancel ആവും. അപ്പോൾ 2 sin t cos t dy by dt വരും, പ്ലസ് lambda cos square t y equal to 0. So ഈ രണ്ട് terms cancel ആവും, and cos square t is common. So that will cancel out. So we are going to get the differential equation d square y by dt square plus lambda y equal to 0. So that is by using the substitution x equal to tan t. So this is the differential equation we are going to get. ഇനി നമുക്ക് ഇതിന്റെ solutions എന്താണെന്ന് കണ്ടുപിടിക്കണം.